We have stickers over here. If people are interested, they're hiding next to the mics.
Do I have to log in differently now?
If people are looking for work, we have a couple of job openings. They are very technically oriented and pretty deep on programming, except for the DevRel. But the DevRel unfortunately is California only. So probably no one here is gonna make that commute. That would be a little rough. If anyone is hiring or they want to mention it, we'll get started in a little bit and you can come up and mention you're looking for people. Or other way around, if people are looking for work, we come up and say, hey, I'm looking for a job, there are things I'm interested in. We'll try to connect you there.
Which website should we do?
There's two, I don't know if one is fake or not, but the J Space Conference is the one that they recommend. There's a J conference without a space. I don't know if that's a scammer. Or someone has a repeater and they messed it up. I don't know. I don't know. I'm not saying I used to work at the NSA, but I know that the. Welcome to 159, all lowercase, and the 159 is a number. It's on the wall in a couple of spots. If you hear that, you get a little close. The Wi-Fi seems to work pretty good. If you didn't notice, the cooler in there has drinks. There's also a couple of water stations in there. Right, these you don't have to water.
I love your.
Well, I mean, still ambient. Hey, New York water.
See. That's me, you see. What brings you here?
One more question. Well,
There is a test later and you'll pass it and you better.
So like purely, your vision. And,
All the slides will be made available and then this is for, we will record this and it works out.
awesome.
filter.
See, but it's usually, they have Zoom cameras here, so in theory they can record.
Okay.
And I just want to learn like, what are some of the applications, how people using it, like what's going on in space.
Oh, yeah. All these numbers. Oh, yeah. I'm gonna ask you this. If they're waiting. Only bring this one side. Yeah, that one we got. I'm just curious. Okay, some people don't like it. I don't know if we should. But I'm saying, I mean, honestly, it's a good idea. Some people wanna eat during the day.
Yes, sir. Appreciate you. Look to you guys, I'll be here if you need me, okay? I'm over there, check out.
Yeah. I noticed that.
What else we got?
Yeah.
We have a Discord, because if you're an AI company, now you have to have a Discord.
Yeah.
But in Discord's okay, we got a chat box there. We've got human input question. The chat box is easy. I mean, and what's nice, the guy who wrote this is gonna be, so that's pretty awesome. So you might wanna join the Discord, so you can test it out. And if too many people tested at once, maybe we can see if it stresses system. No, we started,
It's like.
and then I don't know why, they just like, everyone else is doing this work. I thought you don't like. I'm not paying, there you go, now you found the secret. Yeah. So like, you know what, since the. I can send them to Discord, but reading Discord is me.
Yeah. Definitely takes like a train.
Okay, come on.
Are you kidding?
Yes.
I can't start those.
Oh, perfect, perfect. You got time, pizza, there's drinks in there, the cooler. You have trouble finding the place or just the elevator? Hey, I mean, Unstructured game. Hey,
Yeah. I've used, it's like a mother.
So the nice good thing about the floor downstairs, it's got Instagram mobile behind it, yeah. Yeah. It's better for one taxi.
Visualize stuff. Yeah, but I'm not sure.
We are always looking for speakers. We're always looking for interesting stuff. If you don't want to do a long talk, you can do a short one, you can do a lightning talk. Just let us know. I have cards. You can email, you can scan there. We also, if you happen to be here just on vacation or something, we have meetups in Berlin, in China, in San Francisco, and in the Bay. So if any of those places work for you, let us know. You could get on the list there. There's a little busier over on the West Coast because there happens to be some AI people there. But any of them, always looking for a speaker, especially if you want to do a quick one, or if you do anything with open source, or if you're a Milvus user, those kind of get a bump ahead.
I feel like maybe weird, like, I created a database, and actually just, and I'm like, for example, I have a pitch that I want to find the most similar in the vector space, so I'm just like, the interactive in Python, like, that's what I feel. Yeah. Is that just because of like the X?
Now, I also have some swag here besides the free stickers in the corner. So for people answering questions, I'll pull some stuff out of our box of a handful of stuff. There's some shirts, a bunch of socks, and one of our little Milvus friends here. This particular one has traveled to glaciers. He traveled to the certain places right before there was a disaster. So I don't know if he's good luck or bad luck, but I was able to bring him back. So he's in pretty good shape. If you go look on Twitter, you can see his adventures. He posted that. I don't know what the prize is, they don't know. There's 3 vectors maybe? All the vectors you can carry out here. Here, I'll leave it up.
Okay.
I keep it to time, otherwise I tend to run fast. Fly by this part. The people at home don't need to see this, they don't get this. This is in person only. They can't download any picture, you can't lose it.
What's the name of the Discord channel again?
Oh, yeah, let me go back to that.
Logged in on desktop.
Oh, let me, this, let me see. The links in, this are always weird.
Where?
Let me see. I have that written down. Discord. Oh, that's really small. Let me increase the size of that. Nope.
Mixed case, you know, it's not possible.
Sounds like maybe
Let's see.
It works.
Woo! Something works. Yay. First time. Oh. Okay. We are streaming live.
There's times when I forgot and the audio wasn't showing up.
Which stinks for those home people.
Share your photos so we can download them and put them in our record. You'll get it. Email me.
Sounds like.
You can even see it here. You probably should see it. Yeah. I want people to get nice. Yeah, you're gonna read it.
Hey,
Yeah.
you want to get some food? Again, we've got time. And this is all connected through Zoom, so
Okay, is it okay if I use my laptop or should I share this?
use your laptop, is fine.
Perfect.
Yeah, we got time here. It is, yeah, you're not on until,
7:30. I'll be around. 7:30.
7:30.
I'll get it. I'll be around.
Do we have everyone? I think we do. Correct. The good news is all our speakers are here. Yay.
Yes.
Please go back. So it is, yeah, welcome. Oh, let me send you the link.
So for RGB-X, one of them can be.
That's where the cameras are. Nope.
Sometimes that sort of channel is very. I don't know.
Keep that pause on it. It's like 10,000 things over here, man.
Put my share.
Oh, I could stop my sharing here. But you can see we're on camera. It will show up. Oh, you're over there.
So it's like this. See, this is how I show it. Yeah.
Interesting, it's showing up there,
Showing up, but
you see it, and they see it,
yeah,
I don't see it, which is.
yeah, but I want to see it in a. Presenter view. Yeah, but that's everybody sees that. It's probably.
I'm not seeing that, but other people may be seeing that.
No, I mean, it's being projected.
Oh, being projected
Their
there.
project, like this, the way you are doing.
I'm not connected to anything.
Oh, so you are also the Zoom.
I'm Zoom. I'm trying to think if we could switch to HDMI.
USB-C.
See, this is not connected to anything. This is just my, they do have one in the wall one here. We could try that for you.
How are you? Are you speaking of your first or?
No, you are the first one, maybe.
Or second? I want to ask, is there Wi-Fi?
Yeah, that's on the wall there.
Oh, perfect.
Jade conference, and that works pretty good. Maybe just share a window. I wonder if that would work. Advanced mode. Portion of the screen. Maybe show one window.
Okay. So let's see. Let me try. So if I go here and say share.
Share like just the PowerPoint.
Then I can.
I'm not seeing the,
Okay, so you're not seeing this.
no, that's the way to go.
That's the way to.
It's working. I'm not seeing any notes
Okay, so
and it's showing up in the Zoom.
sounds good.
So that is the way to
How
go.
do I move to the next screen?
Oh, you can't see your thing.
So
Well, I can give you my clicker.
Okay, then I guess, okay. Got it, okay. So maybe there is a way. But
Okay.
please help me then, okay?
Yeah, we'll do as good as we can do. Okay. Give that right one. Swamp that. No, that was in the wrong one. You did this wrong.
Very naive, very much free.
Oh.
You don't have to.
Should I do the mic? Test. We're going to start in a couple of minutes. And as you see, there's 3 tech talks. My talk is not a tech talk. Mine's just some random garbage. So it'll be very quick. Just to show an intro, a little bit on Milvus and some things running. But we'll start in a couple of minutes because every time I want to start, I see a couple more people filter in. So I'll let a couple more come in and then we'll start. If people have any questions beforehand, not a bad time to ask them while we're still warming up. There is still pizza left. Any pizza or drinks at the end of the day, people please take them home. I do not want to sit on a train with 12 pizzas again. That has happened. It's not fun. If you want my slides, they're available here. Again, there's more in my slides than I will talk to, as I'm just a filler until the main event occurs. So whether you want those slides or not is up to you. Now, do we need the mic? Was it okay without the mic? Better with the mic? Better with the mic. Then we got mic. Question.
Can you share some of the sensible steps we've done individually?
Yeah. Well, we are very fortunate in, I have to go in reverse here. Robert is going to show us an example using Milvus database as part of his product, which is also a product we use in our Discord server. So it's a kind of a cool circle there. So that's one. There is a lot of new use cases. I'll see if I could dig up a couple that may be more interesting than others. But if you see new models come out, someone's working on that is along with that. So what's newer stuff in Milvus? Have you seen 2.4? Okay, we'll go off script here. Like I have written a script for this. If you look at the latest releases, I guess we gotta go to GitHub. Have you seen Milvus Lite? Okay. And we won't do that. Okay, in the latest edition in 2.4, now in 2.5, there's some new stuff coming, but we've added re-ranking. If you haven't used that yet, I'll show that in a quick example. We've added sparse matrix, sparse vectors. I'm trying to think what else is cool that's out new. If we look in, this one's cool. We can run Milvus on a Raspberry Pi. And for some reason, that's my most popular article. That's a really cool thing for some reason. Something I didn't realize and has come up recently is about partitioning. When you set up partitioning, that could drastically improve your performance and reduce memory usage. Vector databases use a lot of RAM, especially if you've got millions upon millions of vectors. We have some clients with 1 billion. You're going to want to partition the data because then you're using less RAM and things are a lot faster. And what's nice is it's super easy to do. So I definitely recommend checking out partitioning. That is newer. Being able to have up to 10 vectors in a single row. So you can vectorize, and they don't have to use the same vectorization to get them in. So they can be a mixture of dense and sparse. And you could have one, I do one that has an image and also has text, but you can have up to 10. In the next versions, we'll be adding more. So you'll be able to have more vectors in a single row. Again, you know, if they're related, it makes sense to put them together. If they're not related, probably doesn't make sense to put them together. What else is new? Oh, have you tried BM25 or BGE M3 or some random letters and numbers? I'll say that no one knows if I'm making it up. Or Splade, random words. I mean, there's so many that like it's every week there's a new model and we find a new one to come out. One that we're hoping comes out in 2.5, may wait, is Copali, which is, if you don't know what Copali is, we won't get into it, but it's very interesting. And that one may be in the next version. Again, some of these things are so new, doesn't make sense, but sparse vectors may be helpful to you, depending on what your data looks like and the different algorithms you're using there or what cats you have. Okay, so that's some of the new things, but that is a good point. We'll do that in the next one. I'll get to all the newest fun stuff and make sure we put it in the talk. I'll do a lookup. If you come to AI Camp tomorrow, I'll try to add some of the new features into the talk because that one's kind of flexible. So AI Camp is tomorrow at MS Rector in Times Square. It's pretty full, but they probably will let you sign up until tonight. So you might want to check that out. There's also a speaker from AWS there. That could be interesting. Everything's stored as numbers, but really, I'm just storing cats. These are all real cats. That's my new thing, is telling people if something's AI or not. Not AI, sits in my living room. Not AI, sits in my living room. Not AI, doesn't wear the tie anymore though. He lost a little weight as he's a little older and he won't wear his tie, which is sad. So keeping an eye on time, I'm not going to take any of the time from the professional speakers. So there's a lot of different things work together. That might be something new for Milvus. We're adding new partners pretty frequently to make sure we work well with them. NVIDIA was at the last meetup and talked about the new index that we worked on together, which is based on the small world. It is graph-based, really fast. And surprisingly, despite you having to buy a GPU, will make your cost savings take care of that. So even having a GPU, if you're storing enough data, the performance and the time spent on compute will actually make it cheaper to use the GPU and to buy it versus not having one. So that was kind of a surprise that they got that speed up there. But being able to do floating point numbers massively parallel is very helpful for vector databases. Now, if you want to try out your own demo, we have links to them. Again, we gave you the slides. Those are all live. So you can just go to any of these demos and actually just run them yourself. So we don't have to run them on your own. I'll run just to show you that it's real. I want, who likes Ceiling Cat? I like Ceiling Cat. So what we can do is, this is a multimodal image search. So it'll take into account the image, which will be used for the search, as well as the other part of the search is the text, and it puts them together. Now, once we did that, we could run a re-ranking algorithm, which is a smaller model to get them in more proper distance. Right now, the results are just the two combined just in no particular manner. This does the re-ranking algorithm and makes it more appropriate to what you asked. I don't know. I think the one in the other search I liked better with the actual Ceiling Cat, but I didn't say the Ceiling Cat. I mean, it's, you know, that's up to you which one you think's better. We got a reverse image search. You could do that demo. We've got a very simple demo, just so you could try them yourself without having to install Milvus and Jupyter Notebook and all that. Milvus has been around for a while, almost 30,000 stars. Maybe if everyone clicks twice here, we'll get that. These are real numbers and they're kind of crazy. I don't know how much money this is, but I know it's more than it costs for all that pizza. This is a very large, a large size dimension there, having 1,500. But yeah, someone's with 100 billion. They can afford it, so that's good for them. We have a lot of content that's not fully related to us on the website, just to help people with LLMs and search and kind of fun stuff. What we were showing before is the hybrid search. And that one's kind of cool, is to be able to combine different searches together and use scalars, which are just fields, to be able to search, filter it down based on some attribute, and makes it quicker, give you better results. Especially if you know some metadata about your data beforehand. Like if we knew we were looking for a Ceiling Cat and that's a tag I frequently use, I could have a field that says category, use that. There's no reason not to use traditional database style filtering and not have to do a full vector search for everything. It's not a bad idea, and it's helpful for things like agent search and others. Yeah, I'm not going to show you text now. I don't know what I was thinking there. they're going to read all this text really quickly. Real quick, different types of vector embeddings. We mentioned some of the new stuff. Some of the new stuff is the sparse ones. See, that's real. See, I didn't make that up. It could have been made up, but you could pretty much say any couple of letters and it's an AI thing. And the chance it doesn't exist, there's probably a startup using that already. So these are a bunch of them. What's cool about Milvus is the flexibility. A lot of other vector databases were like, you're good with just IP distance or L2. You only need to get models from OpenAI, or you only need to index with Facebook's. You don't need the flexibility. Well, data is different. It's helpful to be able to use other ones. This is for an article. Is that cut off? That's cut off. Yeah, just download that main one. I'll show you one demo, and then we'll get to the real speakers. This is a Jupyter notebook that is available in GitHub. This shows creating what we saw in that little demo, searching two different vectors together. So the first vector is weather data. I combined weather data with New York City street cameras. So it's the weather around the camera. So you can search and focus it using the two vectors in each row. First vector is the image vector. That's where I put the camera image. So I'm going to search that using an example image. And then I'm going to search the second query is against my text vector. And that's going to be that little line of text I had at the top. Then we combine them. We use a re-ranking algorithm to get them in the right order. I pick the fields that I want. These are the scalar. There's no reason to show a big array of numbers. I don't know why people do that. That looks silly. And then we run it. So that took 0.1 seconds. Not too bad on the laptop. And then we'll just iterate through those results. And you can see the results we got back. And the distance from accuracy, the one thing you'll see with vector databases, unless you want exact match indexes, you're going to get the closest, the nearest result to what you wanted. Because some things are not exact, right? If I'm searching for a similar picture, like I want ones that have a certain number of matched vehicles in it. This gave me back that row of data, which has the image and the scalar fields. Just to give you a quick example. We'll see if our speakers are ready. I know there's going to be a little bit of a switch over as we're going to do a zoom flip, and we'll see how smooth that goes. Usually that goes very poorly. So there may be a short break to grab a slice of pizza when that happens. If people are ready in order, do you want to come up? Yep. And now you got the link I sent you.
Got the link.
You're in the Zoom.
Not in the Zoom yet.
Okay, get in the Zoom. Get in the groove. I'm going to take Mr. Milvus over here. Now, this talk is very interesting. He was mentioning it for the people who were here early and got all the flame and yawn before it was gone. We were discussing some of the stuff he's working on. Yeah, probably mute yours.
We're good.
You're good?
Good.
Now, we also have a clip-on one we can use.
I can hold the mic, no worries.
Okay. Because I've seen your demos, you got a lot of stuff going on. This is cool stuff. Let me stop my share. Now you have to share. Are you sharing?
We're up. Awesome.
Okay, don't trip on all those ones.
I'll try not to for next step. All right, thank you for coming, everyone. My name's Dan. I'm from Voxel 51. We're the lead maintainers of the open source tool 51, which is a computer vision curation and refinement tool for your data sets. We'll be taking a little bit look at that later, but what I'm here to talk to you about is all about RGB-X model development and exploring 4-channel model development in computer vision. This is one of the more hot but also niche topics in computer vision, with a number of papers going into the next conference at ECCV, which is at the end of this month, focusing on this topic. So we're going to be looking at the whole landscape briefly and what it's shaping up to be. So a little bit of a startup here. While stagnation fears rise, visual AI continues to march on. You can see the NVIDIA stock price here tanking, but just in the last 2 weeks, we've had some of the best computer vision models and papers come out, such as this video down here on the bottom right, which is showcasing SAM2, which is a huge revolution for the computer vision and visual AI space. And as we continue to think about this, what we've seen more than anything out of visual AI this year is that this has been a year of scaling, right? There's so many awesome models that have come out over the last 2 years. However, it's time to make money. At least that's what everyone believes in the field. So it's all about kind of setting up these stacks, filling out your flows. That way you're actually scaling your production. That way you can actually get models out that are working, right, for your company. So we see a lot of people connecting to their clouds to these millions, if not billions, sample data sets that they're trying to hyperdrive their training flows through. We see this, scramble for securing GPUs across whether you're the biggest people in the world making visual AI models, or you're one of the smallest people and you really just want one H100. It still can be pretty tough sometimes. But more than ever, we see people building out their stack, right? Because back in the day, we could kind of just throw a folder at a model, say train on all the images in here. And that was good enough for a thumbs up in a paper at CVPR. But nowadays, you have to be a lot more sophisticated. We're thinking about things like data set curation, cloud connections, model experiment tracking. You probably recognize a lot of these logos here. These are a lot of the logos that we see people using in production today. So the main point of this talk today is all about these RGB-X models, right? So the X here is standing for the 4th channel in your image, where you're able to store whatever information you would like to do. So we have some samples here from Sapiens, which is the new meta model that dropped within the last week. That is kind of showcasing some of the possibilities of what you can store in the 4th channel. So some of the most popular tasks in visual AI that we see in the 4th channel are things like segmentations, depth maps, normals. We also think about infrared often. And when I speak about RGB-X models, what I'm referring to is any model in visual AI that is either inputting 4 channels or has the goal to output to 4 channels, right? Both of them are their own individual tasks, but they have their own use cases and workflows that they have associated with that. So when we think about this, it's used across all different industries here. Some of the most common use cases that we see these models being used for today. One here, if we look at the top right, is all about understanding all the different curves and edges in your environments. So we think about things like creating 3D assets, mimicking 3D from 2D images or videos that are inputting to the model. And we use surface normals and depth maps a lot of times for that, to just kind of generate these 3D estimations or reconstructions of environments. But we also see it on the bottom left, we're using depth all the time for self-driving. Self-driving is one of the hottest topics today in computer vision and visual AI. And one of the key tasks that happens in self-driving is depth estimation, right? We want to make sure we're not too close to the car ahead of us so we can hit the brakes in time. The last one on the bottom right is infrared. We have a lot of challenging environments, whether it be disaster recovery, whether it be nighttime, or whatever it might be, that the visual layer of your images is no longer sufficient to get accurate detections. So we're going to pull in the infrared sensor to kind of get more information about what is happening in your scene and have better and crisper detections. This is personally, I've seen use cases in this for things like car detection at night on highways that don't have proper lighting, or in neighborhoods that maybe don't have proper lighting, as well as people detectors, right? Your Ring doorbell still has to work at night. So how is it going to be able to see people at night? Sometimes they're throwing new types of cameras in there to make sure they have more crisp results. Before we get started and we take a deep dive into this, let's take a step back and think, why are these models important in the first place, right? We can think about, infrared's pretty cool. There's some cool use cases there and stuff like that. And while some of this stuff seems pretty flashy, why does it matter if a model knows that I'm wearing a jacket tonight or not? Or why does it matter whenever, it can find a segmentation of my left earlobe or whatever it might be? Why do these models matter, right? We're going to hold this question in our mind as we kind of track through the deep dive today, as we're going to revisit it at the end as a preview for what's going to come. So we're going to start with just how they're being used today. So we're tracking across all signals, right? The number one use case that is currently in production today for RGB-X models, without a doubt, is tracking. This is mainly used by government agencies, military, as well as some other devices, companies and industries, just to make sure that they're not losing track of stuff whenever they have their cameras. Lo and behold, they found out if you throw more sensors and more signals at a detection model, that it's going to have crisper and more fine-tuned tracking, right? So we can kind of track across any amount of frames for RGB-X. There's people that are doing this across all different types of the RGB-X modalities. There was actually a recent paper in CVPR this year that created a new tracking model across all 3 infrared, depth, and surface normals. And you can throw any amount of those at this model architecture if you want. So maybe you have 2 of those, maybe you have 3 of those, maybe you only have 1 of those, and it will generate high quality tracking results based on the inputs. So just a new way to make sure we're keeping track of all the things. This can also think of counting, right? If we want to count fish, if we're trying to count the number of people going into a building, whatever it might be, throwing more sensors at it always seems to help in the long run. One of the more interesting new ones, however, is surveying difficult terrain, right? So we have these really high quality sensors that we're developing, especially on the depth side, where this is more on the input side. We can provide these depth values alongside PNGs of just images and things like that. We send a drone to fly through the area, and when we bring the drone back, we can actually create 3D reconstructions of these areas to get really high quality results. This can even be performed all on board in some cases when there's hard to reach areas and things like that. And one of the use cases that I've seen myself is surveying nuclear reactors. No one wants to go inside the nuclear reactor themselves. The drone doesn't seem to care. So you fly the drone inside the nuclear reactor, take a 360 video of everything going on in the nuclear reactor, and then you can check for any cracks, scans, whatever it might be. And you actually have a whole 3D reconstruction of your buildings, whether it's skyscrapers, interior buildings, nuclear reactors, or whatever it might be. You can also think about this for, once again, for law enforcement or whatever like that. If there's some kind of disaster recovery, if there's some hard to reach places where maybe it's not safe enough for a human to go into that area, like a fire burning or something like that, well, you can throw an infrared drone in there, fly it through, and then get the results to find where these people might be located across, smoky environments, snowy environments, disaster relief environments, where these drones are going to be able to have better insight into what's happening there. The newest one, which is the flashiest one, of course, is this new meta model that came out this week, a little bit earlier, maybe 2 weeks now, where you can input a video. And now this model's hyper-trained, only focusing on humans inside the video. It actually took a very bold approach to say they don't care about anything in the video outside of humans. The model actually completely throws out any type of loss estimations, training functions. It doesn't even look at anything outside the segmented person in the data set. Right? We're only training for the per person task here. And then with this task, we can actually, through an input of your a plain RGB JPEG or PNG, output any of these 4 RGB-X outputs. So in this case, we can have segmentation, which is the highest quality segmentations done yet so far, also achieving state-of-the-art across the accuracies of those segmentations. So no longer are we just saying like shirts, pants, hands, head. We can actually get things like the left inside part of my elbow, my left arm versus my right arm, the different parts of my hair, whatever it might be, my teeth versus my lips. They're very fine-grained on this data set, and they achieve state-of-the-art results on the segmentation. Likewise, on the depth, once again, we're focusing only on the people here, where you can get, once again, believe it or not, from Meta, state-of-the-art results on depth by a large factor. And same thing for our surface normals. We get state-of-the-art results on the normals of people. So basically, Meta took a field of computer vision that they were interested in, which is this human-focused inference, and then just in one paper hit 4 state-of-the-arts across all the different model sizes. Whenever you drop the model size to equivalent parameter sizes of the previous state-of-the-arts, they still achieve state-of-the-art. So not only did they throw 7 billion parameters at this problem in order to save 20 to 30% state-of-the-art further of everyone else, they were even proved that, hey, even when we're fighting in the same arena here at the same weight, we're still better than you. So they did this by training 1,000 GPUs for 7 days each on each model. They use a 300 million image data set, which they all manually annotated for all these poses and segmentations and such. The depth and the normals were coming from sensors that they used during the time of collection. And they had some interesting insights. I don't want to get too depth in this, but this is just the hottest thing on the market this week. It's showing that, when you start from scratch, if you're going to train these new foundation models, they found it's better to train on just people, right, for their pre-training loop instead of their generalized computer vision training data set that they have. And they even showed that it's better to train on 100 million people for their pre-training than it is to train on 300 or 500 million just general, right? So when it comes to feature extraction, especially for these RGB-X tasks, it's important to remember that high quality data and better data is going to train your model to better performance than just throwing a bunch of images from a folder and hoping for the best. So how to get started, if you're interested into some of these RGB-X models, we have some tutorials available on 51 as we do support all these different tasks. The best data sets for RGB-X development and the papers that are coming them are most likely found on Hugging Face, as well as there's a whole bunch of interesting Hugging Face spaces, including Sapien spaces has a space where you can try out all these different models. Also, just as a little side note, some of the best RGB-X models and papers and everything like that are actually coming from China nowadays. They seem to have this whole interested community on some of their universities that is very interested in this niche section of computer vision. So there's some interesting ones called like depth track, as well as there's one called thermal track or something like that, which are depth and thermal annotated data sets, but they're all from Chinese universities. So super cool there. So I can give you a quick example. So if you ever want to try out Sapiens, which is the cool model of the week, just head over to Hugging Face. They have the whole demo here where you can just upload your own image. Here's me at a nice, beautiful Japanese garden. And then I have to move the zoom bar out of the way so I can click my demo. We can load this into 51. And in this case, I have all of them on at once. It's a little overwhelming at once. So we can turn these all off. But we can actually go one by one and see that like here is my depth map where I can load that in and find out my different values. Here's my segmentation map where I showed you those very fine-tuned things where it's very quick to point out my top and bottom lip. We can also look at surface normals in this case to find all the different edges of my body and clothing there, as well as 223 different key points on my body. So it's very hyper-tuned, very fine focused, and it's really incredible. The smallest model that they have is 300 million parameters, but it scales all the way up, I believe, to 2 billion parameters. So it's super cool. I'm really excited to try to do more work with it, try to create some data sets by just serving from it. There's a lot of interesting possibilities that can happen from the Sapiens model. So hopping back into my slides here, there was also actually a really cool paper that dropped today about RGB-X dataset, just a dataset paper. I tried to load it, and the paper is maybe muckus. It didn't work, so I was a little nervous about that. So I'll have to confront the guy at ECCV and let him know his dataset might be a little phony. So we're revisiting the why here. So these are all pretty cool, but in the large spectrum of, we're here at the Milvus Unstructured Data Meetup. We're seeing all these super cool LLM applications, and I'm the guy talking about, flying a drone through a nuclear reactor. Does any of these use cases really matter? Are they moving the needle? Are they seeing them as critical points being used in production today? The answer is no. It's definitely not. It's not. None of these models are really high focused in production today. No one's making money off these models. No one really has found a really great use case for any one of these models to be, successful for them in a way that they feel is important. So if that's the case, why is this work important? Why did Meta just spend, probably millions of dollars training this model to release it to ECCV before we go there? Why is all this work going in this to the first place, especially the money going into this place? And the answer is we need to look to the future, right? When we think about how we're going to use these RGB-X models, we can kind of think about it like building the car, right? And, we hear this idea, one of the buzzwords of the week, is embodied AI, where we're going to have multiple different systems of models working together to execute on some task, where there's going to maybe be robotics or this human-robot interactions, right? And so if we're thinking about that as building a car, we got to build the wheels first, right? So someone had to go build the wheels, someone has to build the transmission. We can't just build the entire car at once. And you can kind of see those RGB-X models as part of that puzzle, right? We're kind of plugging those pieces in, moving towards the future. And which is just interesting, right? If we were trying to figure out a very sophisticated ML system that has all these orchestrated models, which one of these would be better to input it? Would we rather just give this boring satellite view from the left, or would we rather publish this 3D reconstructed environment where it has so much more so much more information to inference on? And so when we think about the future, we think about the things that we see in our everyday life, like social media, TikTok, Instagram Reels is really big. We can very quickly look at these images here and see how that would be useful for these companies that are investing in those kind of platforms to be able to create new filters, understand more what's happening in their samples. And that kind of leads me into what does this mean for machine learning? Well, the number one would be search, right? We're all here at the Unstructured Data Meetup. And so by having these kind of models, not only can you inference on them to predict on the things like surface normals, depths, thermal, whatever you're interested in, but you can also create the embeddings models for them. So this helps you understand your data much better, because you can actually compare things like the surface normals of one picture to the surface normals of another picture. You can do the depth of one picture to another one, or we even have projects in depth today for things like, I don't want to know that I'm 20,000 made-up array values away from you. I want to know that you're 5 meters away from me, right? So now we have these models that actually can do actual imperial metric units in depth instead of just doing, fancy NumPy array depths. And so by using this kind of search, we can have much more fine-grained searches, saying, so many samples that are very close. Give me drone images that are a 30-degree angle away from the target, right? Or give me, whatever for these social media platforms, just more fine-grained search to find the content you're trying to look for. The second one is this idea of embodied AI, especially when we think about self-driving cars. Having spoken to these companies who are developing new car software in the future, it's much more than just not hitting the guy crossing the street. It's much more than hitting the brakes in time, right? Now we're talking about projects of things like, how can I just tell my car to go somewhere that I want to go? How can I point at something out my window and my car is going to tell me what that is out my window, right? There's so much more context both outside the cabin of the car as well as inside the cabin of the car, where I want to track things like the motions of the person sitting in the seat to see if they're having a seizure or a cardiac arrest, so I can pull the car over and call for medical assistance, right? So these kind of advanced embodied AI systems, where there's so many models running at once, we need to make sure that we're giving those models the highest quality information and the highest quality data sets to train on. That way they can have the best results coming out of them. And then the last one is kind of like I mentioned before, the human to digital interaction, this human to robotic interaction. So the best way I can think about this and explain this one today, which is easy, is the metaverse, right? Everyone's thinking about the metaverse. You hear so many of the people like Zuckerberg and whoever it is talk about the metaverse. Well, there's a reason why we see all these kind of papers coming out for things like how to get the depth and normal and the segmentation of a person. So just using a model like Sapiens, I can use existing papers that exist in CVPR and ECCV today to create a complete 3D clone of myself from just a video, right? Take a 5-second video of myself. It's going to know what clothes I'm wearing. It's going to know where my body parts are. And then I can use other common image to mesh or image to 3D models that are available today and create a complete 3D avatar of myself just off a 5-second video. So now, in the eyes of someone like Facebook or Metaverse or NVIDIA or whoever else is investing into the VR world, just take a quick 5-second video of yourself and I can upload you right to my video game or to the virtual office or to wherever you're zooming and VRing into in the future Metaverse of the world. You're going to have that ability to kind of connect to that in a more realistic way that feels comfortable for you, right? And crossing that, human to digital relationship. And this works both in the vice versa, right? When we are dealing with robots in the real life world, right? Where we can see, robot baristas, for instance, or something like that. And no longer are they kind of just jerkily making your coffee, but they can actually react to facial structure changes in your body, right? I can see that your eyebrow raised. I can see that you look uncomfortable, right? I can see that you're heating up or you're walking away from me, whatever it might be. you can actually give context to these robots so that way they can address these and change the ways they act as well, right? So there's a lot of interesting use cases for these RGB-X models. I just don't think any of them are today. But that doesn't stop the amount of money and research going into these models. So there's a lot of exciting things if you look at the trends on the horizon in this kind of field of computer vision. We also have some tutorials if you're interested in trying to do some of these estimations yourself of 4-channel things. We have an example on monocular depth estimation. With monocular depth estimation, you can take a single image, load it in, infer a model on it, and calculate all the different depths of happening in those images. You can then take those depths and then create 3D models of yourself, 3D models of your room, 3D models of your apartment, whatever you're interested in. It's all possible by just inferring this depth in the first place. Lastly, we are hiring here at Voxel 51. If you also want to stand up and have a jacket on and give talks about whatever passionate computer vision project you are interested in, we are hiring. Just make sure to see me or check out voxel51.com/jobs. I can answer a couple questions. I don't know how fast or slow I went. Seems like I'm under the clock.
You are under the clock.
Okay, great. So I'm happy to answer any questions that people have about RGB-X models or any other things that I mentioned in my talk. Yes.
Great presentation. by the way.
Thank you.
More about the RGB-X model, and you said they only focus on sapiens, right? Like on humans.
Mhm.
And I just wanted to know if they focus on just one human or like whatever is in their side, like only humans, but multiple.
Yeah, so Sapiens is focused mainly on like a single person problem. It does work on multiple people, but they have disclaimers in their papers, as you know, everyone would, about, you know, they have different portions of the data set that they've marked, like, hey, this portion is like 20% of our data set has 3 people in it, 15% of our data set has 4 people in it, right? The majority of the data set does have 1 person in it, right? So, great question. Yes.
Yeah, actually, there's one use that I've seen myself. I don't know if you're aware, there's a DoD contract called the SSR-T2 contract, more or less going to be giving drone technology at the student level for Army.
Mhm.
It's not part of the replicator program, but it's comparable. And there's something called Red Hat Holdings, that does the Teal 2 drone,
Mhm.
which you might be aware of. Those guys have interesting software embedded in the Teal 2, which is allows, I think it's through Athena AI, allows you to actually automatically generate battlescapes.
Mhm.
So like what we saw there with that 3D generation, they'll
Mhm.
have that and really good night vision. I'm not sure if they're actually dealing with heat mapping, but I assume they are, because they probably want to literally loft up these
Yeah.
very small, like very tiny drones that you
Mhm.
carry on a knapsack. You loft them up, and within a couple of minutes, you'll be able to have a 3D scape of who your combatants are, what the terrain looks like. And also what's fascinating to me is that it can actually, you could have maybe 4, 5, 10, 15 drones that all stitch all together.
Yeah.
And I don't know if you're following that story, but it's actually, the company itself, it's a tiny company, technically out of Puerto Rico, but their main factory's in Utah.
Mhm.
And it's only it's under $3 stock. Within the next couple of weeks, we'll know whether they won the contract,
Yeah.
or whether Skydio did.
Yeah.
Yeah, it's something you should,
Yeah, so I've seen some of those. I did used to work in the DoD space, so I'm familiar with the interiors use cases of the same exact thing, right? If I'm infiltrating a building, fly the drone through to get the landscape, right? And in terms of night vision, that's actually one of the earliest ML computer vision use cases for RGB-X, where you know, if it's like 7 p.m. at night, like, hey, like my eyes don't really work that well, and infrared's a little too bright for me. Can I get a little bit in between of the both? And that's a classical computer vision problem of blending the two into the most important features out of the two. So great question. Any other ones? Yes.
I have a question about this Sapiens model, kind of like how you see model development moving forward. How come the focus was on like wide variety of tasks, like contours, depth, segmentation? Do you think like these models specialize on like one specific task, or is there like an advantage to having like wide variety because like these tasks kind of relate to each other? Like, how do you see that one?
Great question, right? So clarification to start, might answer your question right off the bat, is that the Sapiens is actually 4 different models. It's not one model that outputs all the different types. You have to pick which one you want off the rack and then say, I want depth. So you prompt the depth model. In terms of the future, very clearly, like in the paper, they state like no one has thrown this much money at a computer vision problem. So we did. And now we have 4 state-of-the-arts. And that's probably, hopefully a trend that will continue, right? This isn't a bad thing for the field to have more money and more eyes coming into the field for projects like Sapiens. So I wouldn't be discouraged by this type of model development. It just, it's a way for us, maybe computer vision engineers, that we need to adapt to the foundation models of computer vision, just like we saw in language. We're going to probably get some of those on the vision side as well, right? In terms of what you're using me for. Yeah.
Great talk, by the way. My question is, compared to like normal RGB model, what sort of architectural differences have you seen that makes for?
It's a great question. So there's 2 main approaches from it, right? The approach that is typical is that you look at all 4 at the same time, right? Just throw it into your transformer, just increase the window, increase the number of layers you have, whatever it is, and just kind of look at them all. Only recently have we seen that decoupling, where people say it's better to train a decoder or autoencoder setup to look at specifically only that 4th channel, extract the features from it in a separately trained model, and then look at the RGB in a separately trained model, and then kind of pull those embeddings together to make an inference on it. That is kind of what we've seen in the last 6 months to a year, is kind of decoupling the 4th channel from the original architecture and then pulling a new architecture just for the 4th channel. But in terms of what architecture they're using, transformers are still, vision transformers are the way to go, right? The Sapiens model is a large vision transformer. Yeah, sure.
So, my question is, why use these kind of models in place of, say, depth sensors directly if you're taking, like, you're going for a nuclear reactor or, I don't know.
Great question. Great question. So there's a couple ways you can go with this answer. One is things like weight, cost prohibitive reasons, right? Swap prohibitive reasons, right? Where it's a lot easier for me to stick a tiny Raspberry Pi camera on my Ring camera or my drone or wherever it is, and then inference on the cloud or wherever I'm going to inference this depth, right? A lot of times this information is captured from not a giant backpack setup, right? It's someone recording it from their home phone to kind of do, right? For instance, if I want to upload my digital clone onto online, well, I'm not going to do that by buying a $1,000 depth sensor or something along those lines, right? So I need a cheaper alternative, right? That's not to say that many times when people are inputting depths, when they're making these depth models, the ground truth is often going to be a sensor, right? Velodyne, LiDAR cells, sensors are very popular.
So it seems to me only in that scale does it make sense to do.
Yeah, because the sensors are expensive, they're prohibitive, you have to set them up, right? There's a lot of other details that kind of muck it up. If you can inference and get the same exact results, then, why go through the trouble?
Oh, I was just gonna say, some people are doing both, as you have a check and balance.
Yeah.
Some sensors are really cheap.
Yeah, depending on like the quality of the paper that you get, they'll have both predictions and ground truth from an actual sensor. And then it really comes up to how you feel is the best to deploy and what use case you are. If you're deploying some kind of SaaS product or, you're deploying to millions of people, you probably can't get millions of depth sensors, right? If you're deploying to a hyper-focused drone that's flying through nuclear reactors, I hope you have a depth sensor, right? So
I hope you have all the technology.
Awesome.
Maybe not, maybe not.
Awesome. Well, thank you, Tim, for having me.
Yeah, it's awesome.
I appreciate it. Thank you, everyone, for the questions.
That was awesome. New stuff and nothing broke.
Nothing broke. We love when a demo works.
If you answered a question, you didn't get stuff, it's because we forgot. So just raise your hand and we'll bring over stuff if you want it. If you don't want stuff, you could lie and say you answered something we probably won't know. We got our next speaker coming up, as hopefully he's on the Zoom. Otherwise, we'll show some random other stuff while he's getting ready, as everyone likes random other stuff. That's fine. Oh, I found something cool new I just was playing with. I don't know if you've seen the Piranha version 1 model. This one helps classify, and you could use it to mask personal information. So I'm going to use that in some of my stuff, and it's pretty quick. It's available on Hugging Face, and it's a nice open model, works pretty well. I tried it out before, and it is pretty cool. It pulls out anything that shouldn't be shown, and it could show you it either as, you know, redacted or tell you what type of thing it was. So that's pretty cool. He's getting on the Zoom. This is just filler stuff. Okay. Another cool one from the Janae AI guys is a very small model that will translate pretty well from HTML to Markdown. And that's helpful for storing context. I'd rather break up a Markdown document than an HTML one. And also, if I'm pushing it to certain channels, that makes it pretty nice to be able to do that. And what's cool is another one that's in Hugging Face. So with Olama, I can run this locally. So I could just do that conversions. And it seems pretty solid. I'm going to try some bigger models. We probably have to chunk them, but are you in? Do you have permissions? You should have permissions. Okay.
Nice start.
Yeah. No, you gotta wait. No.
I don't know if we're following.
Pass the
time.
mic.
Hi, folks. I am Robert. I'm one of the co-founders and the CTO of Inkeep. So Inkeep and Zilliz have been long partners in building this AI assistant. You might have seen some in the wild. Maybe you've tried to build your own. But basically what we're doing here is building these AI assistants, support co-pilots, unified search bars, mainly on, at least for us, on developer-focused companies who deal with a lot of like technical questions. So it might be a company who is trying to onboard users faster. They're trying to engage with users who don't like, you know, asking emails and support. There might be users who are like currently on your platform that are trying to debug an issue. These are the type of problems that they're working with. And just as a brief overview of what we do, we work with hundreds of developer-focused companies to essentially build these sort of support co-pilots for them. And you'll see there are many types of forms of how this works. Okay, so what is going on with Zilliz? So Zilliz, if you might have tried to do this yourself for your users, but there are many types of questions that they're trying to ask here. A lot of them are technical, and that's like our bread and butter. I've tried to kind of give you a brief overview of like how nuanced these questions can be. So these are not like boring, like how do I sign in or I can't log in, right? This is not like a normal customer support bot. Users are asking how to do something. They're asking for code. They might copy and paste code into the chatbot and say, fix this. That's the nature of the inputs that we're working with. In terms of Milvus and Zilliz, so you know, things you have to worry about here are like, you know, what versions of Milvus are you working with, and what are the differences with that, considering the managed version Zilliz. In terms of the cluster, how do you scale the cluster? A lot of configuration sort of questions you might deal with, and then of course the sort of like the routine sort of questions you might get if you're like actively working in this system, like here are a bunch of API things I'm trying to do. I'm trying to query. I'm in Python. I may not be in Python. I'm doing a direct REST request. These are all things you kind of want to ask. Okay. And if you'll be a little bit meta about it, you can try like asking Zilliz, how do I build an AI chatbot? Okay. So you may have seen this sort of like workflow before, kind of like at the core pipeline for almost every sort of retrieval augmented generation app you've seen. It kind of follows in these sort of 4 steps, which is 1, you need some sort of way to get data in a way that's going to be structured. And this is kind of like what we're going to do. And kind of in the middle here is what Zilliz is going to help us with, which is indexing and doing the search so we can retrieve relevant documents, ultimately to get this generation at the end. And so as a high level overview, we're going to, ingest, crawl everything that there is about Zilliz that we can, that we might think that is useful. Index it under some sort of scheme. Traditionally, say 20 years ago or 5 years ago, you're doing very basic full text search to get documents. And then recently we've got better ways to be able to look and analyze this sort of data. And then once you have that system, just think about it as a more sophisticated, robust search engine for you to work with. And the retrieval here is just what can you do to work with the database you have to get the right documents out? And kind of what I'm getting at here is there's going to be ways to implement a weighted scheme of, I want some things a little bit more tuned for keyword. I want more things tuned for dense representations. And these are things you can do with a proper vector database. And then after all of that, you have a way to work with this. Then it's kind of this game of just prompt engineering to kind of get what you want. And a lot of UX, UI, to receive inputs. Maybe you need to ask the user for clarifications, things like that. Okay. All right, so the goal with Zilliz. So this has kind of been a work in progress since the beginning of 2024, especially with the release of Milvus 2.4, which supports sparse embeddings. They have content around their main documentation website. This is thousands of pages. That's the primary source of this stuff. They have a support portal, this is where their support team maintains a set of FAQs. And then their main sort of community knowledge outside of their actual repositories is, the READMEs, issues, discussions, things you might find in their dozens of repositories. So those are kind of the three main ones that we're working with. It kind of just depends on the kind of company you are. You might have seen a discourse form, Stack Overflow. Those are some things you might sort of want to consider. Then the second part here, this kind of just going to be the main focus, I'd like to talk about, and kind of why it makes sense to do this with Zilliz. And this involves a lot of using the core Zilliz features to do metadata filtering, supporting hybrid search with dense and sparse vectors. And then finally, we have all of that. Kind of the goal here is the thing we need to ship here is they want to be able to go to the documentation and have a widget that their users can interact with. So you can go to these right now. Anybody can go there, ask a question. It's there on their docs, and it's as well in their support page on Zilliz. Okay. All right. So that was a high-level overview. I'm going to kind of boil it down to just the Zilliz phase of this. Fundamentally, we basically need as much good data as you can get. So I know this is an unstructured theme, but you do need some structure here. And in terms of documentation or the internet, there's some pretty basic ones that you can think about in terms of okay, this is the page, this is the title. Here are, the path that I'm in, things like that. In terms of Inkeep and what we work with, we kind of try to elevate that one way or another to basically use this sort of information later on. So this might mean is this an SDK API reference? Is there code? Things like that. What version of Milvus is this piece of information? Is it talking about? Those are types of things that you might want to know. And then there's also a sort of a priority or a notion of which sources are more important than others. So a community response on a GitHub issue may not be entirely accurate versus something stated officially in the docs is going to be. So these are sort of just information that you're going to want to use later down. It's going to make your life easier. And then indexing. The bulk of the indexing process with Milvus that we're doing, or Zilliz, is it kind of revolves in three different modes. We want traditional BM25 sparse vectors. What this means here, as a short primer, is we want to be able to do basic keyword searches. So when I search Milvus or Zilliz, I'm not going through some fancy OpenAI ADA model. I don't need to do that, right? So that covers that case, And then you can kick in the sparse and dense models here. And what I mean by this one is you may have heard of Splade, MPNet, MS Marco, or OpenAI's models here. The sparse ones here, just think about it as a fancy neural model to get a keyword. So when a user says, how do I log in? It might be very close to how do I get started? Those are sort of the things that a sparse neural model can fix. Authenticated is likely to be close to login, things like that. So you're gonna want to be able to use something like that. And that's what that type of model like Splade can do. And then your dense model is just like a general, kind of like what we've seen a lot of development recently of people asking very general questions. And it's a very good metric to have. So again, same sort of idea, like how do I get started? How do I log in? I'm having an issue, I have a bug. These are the sort of metrics that you want to be able to work with and configure in your search so that you can get the right documents out. Okay. So I like to just like walk through a few examples of what do I mean here by when you're working with any sort of data set, try to get the most information out. For us, we do a lot with web pages. You might have seen folks who are like particularly tuned with like PDFs, things like that. For our world, a lot of it is things that look a lot like this. So this is a page from the Zilliz docs. And I've highlighted a few key points here. So if you just did, a basic chunking sort of like text here, and then you're looking at hybrid search, it is not enough to just like isolate that sort of piece of information. What is important here is to look at, the records before it, the records after it. It's in a section called in the collection section. It's also under the cloud guides. It is not in the bring your own compute guide. So when we do this ingestion phase, it is important for us to be able to pool all this sort of information and kind of keep track of this sort of stuff. Without getting too far into the details for us, basically a root record is basically the hybrid search section here. And think of that as like the unit of like record that we're working with and kind of connecting everything together to build a lot of records. Here's another one. API pages are always fun, especially if they're like auto-generated and stuff like that. On our side, it is a little bit tricky because if they are auto-generated, we actually do some tricks to like go to the root and like generate other forms of this automatically as well. So they're a little bit better. But for this example, this one here is a REST API reference. And I've highlighted some key points here. Like this is V2, it is not V1. That's going to be incredibly important. And then it's in a cluster operations section. And then the examples here are also very good for LLMs to be able to work with. Okay. All right. So ultimately, like the pages come in, they just like we have this ingestion engine, and think about it this way, and it's just producing a lot of high quality documents, and we're kind of just tagging it with everything that we do, and we may or may not use sort of LLMs in the process. It's kind of just a matter of like costs, performance, latency, and stuff like that. So source type, like is it from the site? Is it on their blog? Is it on a documentation page? Is it a support page? The record type here, text, code. If it's code, what kind of programming language is it? What version of Milvus is it referencing? And then a lot of hierarchical stuff here, which is basically trying to tag as much as possible, like where is this unit in like reference to everything else. So if it's in a subpage of a particular section, you're gonna want to know that. And what are the nearby sort of pages around this sort of document? And then I've added some extra ones here that are useful. URLs, the path, any sort of tags, and then like dates, things. Those are all things that you can use in sort of like your document processing. Okay. All right. So to reduce this down, ultimately all this stuff needs to get embedded. For us, the text that we're working with is like that small chunk you found, and kind of like everything, just think about like all the information you found, try to package it together into like a cohesive document. And the techniques we're using here are, again, these sort of like 3 sort of models. And the goal here is basically for every record, there is some sort of like primary text that we want to be able to embed. and each one of those text fields get multiple representations. So we'll send one sparse model displayed to Zilliz and package it also with a dense sort of column, and we'll pick one. I don't want to get too into the details of these models, but know that this is like a thing that you can work with. If you're trying to build one of these like from the start, you should just know that these things are sort of just like parameters that you're working with. And then know that, you know, when things go wrong, this is one of the things you can do to perhaps make it better. So a lot of times when folks are starting with like, okay, I have a bunch of text, let's just send it to OpenAI, forget about the cost. And let's use Zilliz. Let's just see how far we get. And from there, you can start tuning things. And it might mean, okay, I need to fix the text. I need to fix the model, things like that. Okay. And kind of one of the core sort of features that Zilliz supports, at least in the latest one, 2.4, is the hybrid search. And why is this important is basically there's not really one unified sort of embedding model that can just get you whatever you want. You're going to want to be able to run a search on multiple metrics. And at least in Milvus, there's two ways to do this. They call it a weighted scoring and then a reciprocal rank fusion. A weighted scoring basically takes, like, say, a score from the keyword matches, 50%, you know, normalized under some scheme, and then the dense vectors, 50%. Small checks, like folks might do, is based on the number of words in the query. If it's like less than 5, it should probably be heavily weighted towards the keyword. If it's a long paragraph, likely it needs to be weighted more towards the dense. Things like that. Okay, so yeah, just to wrap this up on this pipeline again, this is kind of where we're headed. So we've got a bunch of documents coming through, we've processed it, we've indexed it, and now it's kind of the core product to build any sort of AI support copilot with Zilliz. Okay, and just to give you an example of like what happens here, I asked a question, it goes to the bot. And here, you know, it was, I think the question was like, I have a connection issue or something. We take the question, we'll embed it. We go to Zilliz and we say basically, okay, these are the questions. And we might make multiple queries to Zilliz. And we'll pull, say, the top 10, 100, or, you know, it kind of depends on your use case. We'll do some sort of re-ranking, whether you want to use a model or not. And then ultimately you need to package this prompt. This is the prompt engineering sort of game, which is, okay, you go to the LLM, you go to Sonnet 3.5, you go to GPT-4, and you say, okay, the user asked this about Zilliz. Here is like what I'm working with. These are the documents I think will like help craft an answer. Now please craft the answer. And then in terms of our UI, UX, we try to do a little bit more so that folks can get like a nice sleeker interface, including like the sources here. We'll try to basically, anytime the LLM needs to cite something, we'll show you this card that you can click and like send a link out and stuff like that. Okay. And then just like a preface here, like the goal was like an AI chatbot, but understand like by the time you've gotten here, you actually have a pretty good sort of system to do a lot of things. And that just includes a basic unified search. So here's an example that I've pulled from just Zilliz benchmarks, bunch of documents. And in terms of where it's coming from, it's either in the official documentation. Sometimes there's some like blogs or on their main website that might mention something about benchmarks. And then on the right here, there's something about benchmarks in a GitHub, like a repository, a README, I'm sure. Yeah. All right. And then just like why use Inkeep at all? Kind of once you have this sort of system going and it's like part of your either your user experience or customer support or something like that, you have a lot of insights now to like what like you need to do with your product. basically. You might know now, for instance, that the bot keeps saying, I can't find anything. Like, did you know that? Did you even know that? That's like something you can now answer. And be able to ask questions like, what are the top 5 types of questions my users are asking? So ultimately now the outputs of the bot are actually another data set that actually have a whole another application. You can imagine asking the data set that this AI chatbot produced, what are some questions that my users are asking related to connection issues? Or, you know, what languages are not supported apparently by Zilliz? Everyone keeps mentioning, I don't know, like Kotlin SDK. Did you know that? Those are some things you can do with this sort of data that's coming out. Okay, that wraps up kind of the overview of Inkeep and Zilliz. I want to just take a good amount of time to kind of go through some questions. Yeah. Yes. Yeah. Yeah.
So has it there been an attempt? Okay.
Got it. Yeah, I can give you a few examples. So this is not one that's live with Zilliz, but the basic product we have is just a like public bot. Everyone has the same instance of the bot. There are instances of this basically where you can put it inside of your product. So you can imagine a scenario where the AI copilot's inside your Zilliz account, and it now knows, for instance, like the cardinality of all your collections. It knows if you even have a dense vector even included at all. And so for us, there are ways to build these like what we call like contexts or workflows. And it's up to kind of like the customer to like attach this, and it's like all seamless. Like you don't actually have to make it like obvious to the user that they even knew about it. But they would do something like this, which is on every single query to the AI chatbot, here are the last 5 queries I made in the Zilliz like console. That's the type of thing. And they can work with that. And it's up to them, really. We don't really know what they're doing, but like that's something they can do. Does that help answer your question? Yeah.
Systems out there, and if
Yeah.
as this code base, or whatever it is, and then
Yeah.
hey, how is this implemented? That comes out saying that.
Are you asking, like, just to rephrase the question, are you asking for situations where like things are out of date and you need them to be like upgraded? Or
Yes, so for example,
yeah,
bank, they have some systems.
Yeah.
Written code or some old documentation.
Yeah.
They don't want to break it.
Yeah.
The integration points.
Yeah, so that's something that we've worked on. Basically, depends on the platform. For instance, we have like, think of it as like we call them context mode bots. I mean, like models for us. You can basically say, instead of going to like GPT-4, you can basically swap out a model that says GPT-4 imbued with Python SDK, or like Python, like the literal Python or something. And then you would use something like that. And so you took that model and then you put it into your Cursor Copilot instead of a general purpose Sonnet 3.5 or GPT-4. And then you would use that basically to now get a very targeted way to work with your specific system. So in ours, we've seen a few cases of this, and I think it's mostly around upgrading. And like writing tests for this specific thing. Yeah. Yeah.
So somebody says that.
Mm-hmm.
So.
I want to say it's the same thing because like in one sense I want to say you can do that already with like an LLM, and I'm trying to make the case of like why would you use another service, and for us the way we would do that actually is we would analyze the heck out of your code and say, okay, basically like I'm trying to figure out where is authentication implemented in my code base. That's not a thing that normal retrieval systems can figure out really. But if you do this sort of like retrieval system, you can ask questions like that. So you're in the code base now and you're asking, okay, what does this do? Or like, where are my like risk areas when I'm like thinking about a change? Yeah.
We were here last month. Well, we weren't here. We're at SAP. Their beautiful little building. They're actually doing that for ABAP, which is SAP's legacy language, and they're working on some LM, and there's some code, and there's some stuff, and they look like they're able to do it. We have IBM here today.
Yeah.
Are you guys doing that for COBOL?
Right, so there is a IBM product.
Yeah.
Exactly.
Question. Yep.
Okay, so you have one version and it. Documentation, you know exactly what is changing.
Yeah. Good question. So the question is, how do you keep this content up to date? And that's kind of like what we do as a managed service. For us, we basically, like, it's on us to be able to figure out the updates. And usually it's like most people would think it's a costly operation because if you don't do the update, then you have to basically say re-index all of your data, somehow insert everything, and maybe like deal with downtime and how to like switch that over. So those are not fun things that you want to do. For us, basically what it comes down for us is like, how do you build an API on our side that says, I need X documents updated? We can implement that cleanly without any downtime. And then we can basically service any number of sort of updates. It's a little bit tricky, to be honest, with web pages because sometimes you might make one edit in one file, right? And that effectively changes all the documents. Which like, how do you deal with that? And that's like not fun. So an easy example I can imagine is if Milvus upgrades to 2.5, and that's like now their new latest version. You want to be able to send those updates as fast as you can. For us, in terms of like a product sort of thing, we found that like generally speaking, like most folks are okay with a system that like periodically updates like every 24 hours, and then have APIs for them to be able to pinpoint manual sort of syncs. Because it's not quite as cheap as like traditional search engines, it is not really worth it to like be re-indexing all the time. Does that help answer your question? Okay.
What about when like Google's offers like a secret?
Yeah, we actually haven't seen in our case that actually even working, to be honest. And the other thing here that I didn't really talk about is performance actually is a really, really important to our product. You can have an LLM that has 1 million tokens. I guarantee you it does not return in 5 seconds. And at that point, it's not usable to anybody. So there is a trade-off here that we're working with. And so for us, we're not looking for the perfect solution, or this is not the one that they're willing to commit to. So if you're like, say you are a customer service representative and you understand the costs, okay, in your basic free bot that literally anyone in the world can go to your website and use, okay, maybe, yeah, I want like an okay model that's cheap and is fast. And then maybe you're in a world where it's like very high fidelity. We've seen this in cases where it's inside the product and maybe they have more sort of enterprise, grade contracts. What we might do there is, okay, it's okay if it's like 2 seconds lower. It just be more right. And those are sort of, for us developers, I think one thing's as fast as possible. It's really hard for us to quantify the gain, honestly, because like a lot of things we're tracking actually is the query comes in, we're taking the time it takes to embed that query, what the time is to make the vector search against Zilliz. Hopefully all of that clears in less than 300 milliseconds. So even just like understand the basic components of this query, you're already at 300 milliseconds. And then you need to be able to go to the LLM and get your response. So we've always run experiments with many LLMs of like, okay, if you increase more, do the answers get better? Probably, but is it worth the trade-off? A lot of times not actually. And we sort of, at least for us, we work with an interesting user base because I think developers they have a higher standard, but they also know how to work with the LLMs actually. So they know actually like when it goes wrong, they actually know how to like ask the right clarifying questions. So it's a good sort of user base to have as like as a primary customer. Yeah. We do have like secondary users, and I think they're less concerned about speed and latency. So we will deploy a bot on docs.zilliz.com, and surely like there are going to be support staff within Zilliz also using it, or sales engineers also using it. I don't think, honestly, they care too much about the speed. And they might want this option to, okay, yes, I'm willing to spend $10 on an LM call. Let's see what happens. Yeah. Question? Yeah, there's two types of discovery here, I think. One, I think if you have anything, I think let's just you built like the worst bot ever and you actually started using it and like you like let it go in prod, you'd probably find either one, your documentation sucks, or the bot you made sucks, right? And I think those are both good answers, I think. And then in terms of like what we'll do is I think, as we've done this like more and more times, we kind of know, actually kind of expect like what will happen. Before they kind of will happen. And a good example of this is like sites with like a lot of duplicate information. It's just like all over the place. It's duplicate information. And then we basically have to spend more time processing and like removing that duplicate sort of information. So that's like an example of thing we might do before something ships. And there's basically a separate pipeline for us on our side to be able to go through and assess the quality of the documentation. And then once you do roll it out though, you might get something like this. Like someone rolls it out, Zilliz rolls it out, Tim's asking questions, and he's like, no, the bot definitely should have gotten that, right? Or he finds a separate sort of thing, which is, oh, we don't have this anywhere. And I think both sort of questions have good answers. And if you keep working with that feedback loop, you can pretty much fix all the issues. And I think one way for us to think about it too is a lot of this can be just fixed like early on actually. And then the rest of it is more like product sort of level things of, oh, we really didn't have this SDK or something like that. Does that help answer the question? Yep. Yes. I think a thing that I didn't really talk about in this talk is there are some queries that are just very difficult to work with. And you've seen like graph attempts and hierarchical attempts try to deal with this. Is a basic one that I'm sure that will break the bot is like, tell me all the changes between version like 2.1 and 2.4. or between 2023 and 2024, what were the major highlights? Those type of queries go very, very bad in these sort of systems. Yeah. I think. Yeah, I think those are some good examples. Yeah. Sorry. Yeah, this one. Yeah. So the question is the chunking strategies. Basically for us, by this point, we kind of know what to do, but early on, it was a lot of our own evaluation on how to do this. And it involved with keeping track how we did it for each type of record. And then we would go back to the end and say, okay, based on like your answer, the optimal answer, what was the optimal retrieval strategy? And like what type of documents were being pulled and why. And if you keep working with that, you'll kind of understand, okay, these are the types of things that you need to do. So very basic examples I can give here is like pay attention to how much text is actually in each unit record. I think a lot of folks sometimes get in the situation of, okay, there's 1 million records here. Each one's one sentence long. And then there's like a bunch of records in another set that are each like paragraphs long under the same sort of like chunking strategy. So like an example I would give is like, if I literally went into every Zilliz document and I picked every single like HTML header 2 and I chunked that way, it seems like an accurate way to be able to go about this, but what you'll realize is like that type of strategy is not consistent across every single document. Because you know it's not Tim literally writing all the documents. Someone wrote one section of the documents one way, and like someone else wrote it another way. So you do have to think about more general ways to go about it. But yeah, I think the short answer here is like there's many sort of things you can do, but just have a kind of like a method to this madness of like tracking down why certain documents got selected. That doesn't allow you to. Yeah. I think, well, for us, the proprietary bet right now that we're taking is that like we've already isolated ourselves to developer sort of documentation. And we're pretty good at that. So I think in terms of like, yes, we do not have a general web scraper that can crawl anything and understand everything. So we did make that sort of decision. The other thing here is I think also it is not as diverse as you think it is. And the third part here is now third part here is like the way we generate content is gonna change. I think there's gonna be this notion of like, how do I produce web pages that are good for LLM consumption and not human consumption? Yeah. A pretty simple example I didn't talk about here is like, think about the amount of JavaScript on web pages today. The more JavaScript that you have, it's going to be pretty hard for an ingestion system to work with. Companies have already built businesses on doing this anyway to convert things to be, you know, SEO friendly. But very basic scenarios can break down to a normal ingestion pipeline. Like I'm on a website and I need to click all the buttons on the page. And it like each one is like a JS click that takes 5 seconds and needs to render, that sort of situation. I actually do think that's going to be a pattern a lot of the world is going to move away from. So that I think is kind of like a consulting for the next generation. Yeah. Yeah, I think there will be an SEO, like an SEO for the next age of LLMs. Yeah, that's a good point. Yes. Mm. Yeah. Yeah, just to give you an insight on us, like what we kind of just fundamentally believe is that the root original data structure is not optimal. There is some optimal intermediary data structure. How do we build adapters to get to that phase? It might mean there are like, literal if-else statements. It might mean use an LLM to help get us to that stage. And that is the data set that we're working with. And we're, that is a very, it's a very research heavy topic of like, what does that structure look like? Yeah, and you've heard topics of like folks, trying to work with like, yes, like, are we really going to be working in the world of like unstructured PDFs forever? Or are we going to move towards something a little bit more structured? And that's like the new unit of work we're working with.
I wanted to show them.
Yeah. Oh, you wanted to show?
The question that he asked, and we got a good answer back. So I wanted to show.
Oh, you should do a live demo.
Yeah.
I think you asked a lot of questions in the Discord.
I use this, man. Your stuff is useful. It's not. I was like, oh, let's see how good is it, and it's good. So I don't have to ask questions like you were asking. What's new in Milvus 2.4? So I asked it, and then it instantly comes back with a couple of suggestions, which are decent. I mean, this is a good article, but then it gives me the answer. And these are good answers because we got the new GPU index with NVIDIA, got multi-vector and hybrid search, sparse vector support, and he's got links in there. Nice. Grouping, inverted indexing, new data type support, segments. Oh, I don't know what happened with that bolding there.
A Discord issue, maybe.
Yeah, there's only so much junk you can push into Discord. And with the sources linked. Good job.
Citations have always been really.
Yeah, people
important.
like that. That makes it seem like it's the real deal.
Yeah.
Thank you. That was awesome. It's nice to see the sauce that's something you actually use. So now we got one very cool talk from a new library. And as part of people like, oh, AI is the evil. Well, this is the AI Alliance, and this is the other side, right? These are the good guys. These are the good AI guys.
I'll be around if anyone wants to start. Thank you.
Yeah, if you want one of these, forget.
Share.
Yeah, I just assume it's gonna work.
Okay, share. Okay.
Yeah.
Now, okay. Hello, everyone. How is everybody doing? Says, yeah, everybody's still here. Okay, great. At least physically. Okay, so my name is Santosh Borse. I work at IBM. My team is working on preparing data for large language model. IBM has its own large language model called Granite series. And we all know that it is, so before that, how many of you have ever tried training your own model? Yeah, some of you, right. So training a model involves preparing data as a first step. And it is one of the most time consuming and time involving step. We understand that we can train a model or tune a model with even couple of files. But when it is a time of pre-training where you're actually training your models from scratch, you need to have a lot of data. Is my voice is audible, right? Right. So it's proven fact that increasing quantity, quality, and variety of data for pre-training is is very important and improves the general intelligence of the model. In today's talk, I will spend some time on the challenges of data. How do we get the data, the various data sources we have? How do we make data ready for pre-training? And the cool tool we have at IBM, which we have recently open source, called Data Prep Kit, which how do you can use that that tool to prepare the data for your own training. And then we can, if the time permits, we can go through the actual exercise of starting with input data and see if we can reach to a cleaned data for training. So you might have heard this cliche term a lot of times, that data is a new oil, right? So and it is coined in a term that the way data was, the oil was very useful for the economy in 20th century. Data will be used for that purpose, where data is a new oil. But if you think it in the other way, the way oil is being extracted, it needs to be found, it needs to be extracted, it needs to be cleaned, it needs to be refined, and it needs to be moved across to get value out of it. If you see, same needs to be happen with data, because data in its crude form is not directly useful. So you need to prepare the data, you need to clean the data, you need to move it through various processing steps to make that data useful for any real world purpose. So usually LLM models are trained in 2 stages. One is pre-training step, where you throw a very large data, which is you train the model on next word prediction task, where it is unlabeled, unstructured data, where model learns what is the association of one word with the other words. And the second step is actually refining or fine-tuning it for your own purpose. So it could be using for the question answer or whatever the end use case. For almost all open source LLMs we have, even though the architecture is open source, the weights are open source, we are not given the actual data recipe or actual data they used for training. So data is still behind the bars of these companies, even though the models are made public. For example, ChatGPT-3 paper says that it was 45 terabytes of data was gathered for training their GPT-3 model. Usually the data mixture for pre-training of these large language model constitutes a different areas. For example, many companies have their own data sets. Usually they are manually curated as well, or they have purchased from the other companies. But the large chunk of data comes from the internet. Internet is still a huge source of data. I forgot the name of the person, but he's a CEO somewhere, and he said that in next 30, 40 years, when we look back, we will see that the one of the important purpose of internet is to provide a data for large language models, and it did it well. So that's what it is. So one of the source of data is Common Crawl. Common Crawl is publicly available free data sets. It has it's crawling internet from 2007. So if you go to their site, you'll see that there are different crawls. So recent crawl is from August 2024, which is from August 3rd to August 16th. So So the knowledge is up to date up to August 16. And almost all the models, irrespective of their size, has used Common Crawl as one of the base. There are even data sets available, which is in the form of paper and code, is the derivative of Common Crawl, where they take Common Crawl as a base and then run through a various cleansing and processing steps to come up to a kind of a data set, which they then they use for the model training, and then claim that this worked or this didn't work. Apart from Common Crawl, there are a lot of data sets available on Hugging Face. You might have your own data in form of PDFs, books, and Excel sheets, Word docs, and it can be any it can be in any format. Sorry, I just have to go through this. Okay, so data quality is a huge issue when we collect data from internet, because internet is a huge data. You see, Common Crawl is hosting petabytes of data. But most of the data is not useful. It is full of content which is not desired from any meaningful purpose. It has a lot of bias. It has a lot of hate, abuse, profanity, and all other contents. So when we say data quality, what we mean by is we want to have a data which has a good variety in it. That way, the model learns a good knowledge. It extracts a good knowledge from that data. Linguistic pattern, if the data is just about the American English, then it may not be useful in other parts of the world. Likewise, if we have a data, very good quality data, but only about certain categories, then it does the overfitting for those categories, and inversely underfitting for the other categories. Data may have personal information. You'll see internet has a lot of leaks about people's personal information. And if we just ingest that data as is, then your model has learned that personal information. Even though we put a lot of guardrails on the model in a fine tuning, it's still there. That information is still there, and it's just matter of doing a right prompting to bring that data out. Likewise, there's a lot of bad data out there, and one thing about the quality of the data is if you're not conscious about the quality of the data for the training, then it increases the time required and the cost required for training. But these companies are spending fortune to actually training these modules, and even like 10% is a lot of money. So here's an example of good data versus bad data for the model training. So good data is usually having less or no duplicates. No typos or spelling. Consistent format. It is validated. Not like, for example, Wiki PDI is considered to be a very good source of data because it is being verified with multiple authors. Whereas any random sites, the data is not that validated. And for model, there's no way to distinguish unless we have it as two different sources and a different weightage while training. And good data needs to be a safe and secure without any toxic contents. So here's some data cleansing steps we have to do before the data is ready for training. So very, very important is deduplication, because internet is full of duplicate data. There are a lot of places where same news, usually it happens with the news, where same news excerpt appears on various sites. It could be exact duplicate, or it could be something called as a fuzzy duplicate, where the two text looks similar. They are not exactly same, but they are quite similar. It's called fuzzy deduplication. There are some documents with mix of the languages. So if you're training English only model, then you want to make sure that your training data doesn't have any other languages. And then there are some content filtering, privacy reduction, and rule-based cleansing needs to happen. And then you can imagine any kind of processing which improves the data quality needs to be there. Yeah, I think come out. Okay, so here's a data journey for IBM's own Granite series model. We lost the share. Okay, share. Share is okay. It's working now?
Yeah, it's working.
It's working. Cool. As we know, this single largest source of data is Common Crawl. IBM's Granite series model is also using Common Crawl along with other data sources. So you can see when we started the data processing, the size of text extraction was 21.7 terabytes of extracted data. This is from the technical paper which we have published along with the models. And then we removed the duplicates, and you can see that it almost removed more than 55% of data just by doing a deduplication. And further processing even reduced that data to less than 30% from the point it started. So this is a data journey for IBM Granite model. So on the top right corner, you can see the various steps being performed on the data. So first was exact dedupe, where we check the documents and see whether they're matching exactly. The next one is fuzzy dedupe, where to see if they're doing bigrams, n-grams, trigrams, to see whether the documents has some similarity, and based on certain threshold, we remove the deduplication. Another is language identification, where we remove the data which is not English. Then there is different filters it goes through. For example, hate, abuse, profanity, where IBM has its own model. So for model training, we use another model to understand whether that particular document which is going to go for training has any hate, abuse, profanity. And if it goes beyond certain threshold, then we remove the document, or there is a way to clean the document to remove that for processing. And then there are different filtering, and the last step is obviously a tokenization. And then you can think of the same steps of process for any fine tuning or any RAG application. You can do similar kind of filtering processing. So this takes us to our data prep kit. So data prep kit is a Python-based project which we recently open source. This is the URL. So you can take a note of. It is a tried and tested piece of software, because this is exactly the software we use for training our own large language model, preparing data for it. You saw that we started with 27.8 terabytes of data and did a processing and reduce it to more than 70% of it. It uses the Ray and Spark runtime. So you can write a logic in plain Python, and it has inbuilt framework which can take your logic and do a full data center scale by using Ray or Spark. As developer, you don't need to understand Ray or Spark because the framework takes care of that. There are a lot of more than 20 plus inbuilt transforms where many of them are for the language data and some of them are also for the code data. So you can, there are various modalities of data. Right now we support language and code where you can take a code. And if you go to this data prep kit, you will see a notebook where you can download a GitHub repository, download it as a zip, and then run that zip, run your code zip through this data prep kit to get a data ready for your pre-training or training. As I said, it can run on pure Python or Spark or Ray. The scaling logic is abstracted. Another good feature it has is checkpointing. So let's say if you're processing very large data, then checkpointing can save you from restarting your data processing from the scratch. Let's say for some reason the data processing stops in the middle, then relaunching will start from the point it stopped. That way it's very, very useful, and it sounds may not sound that useful, but when you're processing terabytes of data, it is really, really useful. I don't know why I'm. Okay, so here are some components. Sorry. Every time I think I press escape, it going away. Okay, so here are the components of data prep kit. So on left side of this diagram, you can see you can start with PDF or HTML or a GitHub repository or a Hugging Face or a Common Crawl as a source. And then there are source converters inbuilt, which is, for example, HTML to Parquet, PDF to Parquet, code to Parquet. So Parquet is a Apache Arrow format. It's a column-wise data format used by many newer data processing engines. And then framework works on these Parquet. So Parquet is the input, Parquet as the output. And you can see these are the existing modules. So fuzzy deduplication, exact deduplication. These are the inbuilt modules which is already present on the data prep kit. And you can build your own also. So framework allows you to bring your own transform. I will show you how you can write your own transform. And all these can run on your laptop, or it can run on your regular local Ray cluster, or it can also run on Spark cluster if it is available. And along with that, we have a Kubeflow pipeline. So you can create a Kubeflow pipelines out of it and run your data processing through that. So this is the example of bring your own transform. So you can see this is a no op transform. So this is like you can think of it as a template transform where it extends abstract table transform. And in transform method, you can see right now it is taking sleep number of seconds as a config parameter and sleeping for those many seconds. But this is where you can put your own logic where the input table is available and now you can take it through a filter, or you can process data wherever, whatever manner you like, and return a table, which is a list. So then you can even split the data into multiple tables and return to multiple table. And along with that, there's a metadata. So metadata acts as a memory of what happened to the data. So every processing or every transform it goes through, the metadata is being collected and it is being summarized. So that way it creates a data lineage of what happened to your data, at what step, how much data was reduced, how much data was kept, and how much data was removed. Okay, so here is one collab notebook I have. So if you want, you can also open it on your laptop and we can walk through together. Okay, so let me see how I sharing. Okay. Okay, I see. Stop sharing and share my desktop. Right, so restart session. Okay, so this is what this particular demo or notebook does. It extract the text from PDF file as a first step. Then, because PDF is made up of multiple section, it splits the one PDF into multiple chunks. Then we run exact dedupe. Then we run a document ID generation, which adds a new column to a parquet, and it gives a unique integer document ID to the document. Then the number 5th step is fuzzy dedupe, where it tries to find out, are there any similar kind of a documents based on the configuration? And the next step is to vectorize and create the embedding out of it. Okay, so this is for example, this is the data set. So this is one PDF where it talks about solar system and Earth, and another is this PDF. It talks about solar system and Mars. And you can see solar system is common in these two documents, and this is to show the deduplication part. Okay. So we checked whether we are running in Colab or not. Let's get the input data required. So here we get these PDFs and utils, which has some util Python functions. Let's install this data prep toolkit transform ray. So we have, as I said, we have support for pure Python, Ray, and Spark. That way you can choose your own runtime, and based on the runtime, you can get the different libraries. So this is the library for Ray runtime. So it's gonna install this library along with the other packages it depends on. We previously imported this. You must restart the runtime in order to. Okay. Didn't I do the? Okay. Okay, so while it's installed, let's see if I have any questions. Yeah, go ahead. Right.
sort of fuzzy deduplication, augmented data,
Right.
Why is it important to remove it?
Right, because this overfitting, right? If you have, let's say, one news source, let's say, usually what happens is whatever the viral news is usually appears on all the places, right? And if that news appears on, let's say, 100, then your model is overfitted for that particular news, versus the other news which is maybe important, but it doesn't appear on all the places. Yeah. Uh, no, it removes the page numbers, but it creates a chunk. So I'll show that. Let's see if I can show you. Maybe it has some. I don't know why the install is not running. I was thinking that is this worked so many times though. So now is the time to fail. And maybe I run so many times without actually buying from Google. They somehow know that now this is a yeah, something, yeah, something useful, yeah, right. Right. So this is let's see, hopefully this runs. So this is the PDF to Parquet converter. So you can see all the transform has certain way of taking inputs. So local configuration is where you specify the input and output. And this local configuration may point to S3 bucket, or it can point to some other data source which you can write adapter for. But S3, it is supported out of box. So you can give directly a S3 address as an input and output. This is the configuration. So you can say output type is going to be JSON. And I guess here you can add more configuration parameters to say, to tune more the PDF to Parquet generation. These are the configs. So data local config. Local means we are trying to read from the local folder. Data S3 config will be for the S3 and so on. And this is another configuration. And we are launching it. So it's going to run through all the input files, all the input PDFs, in this case 2, and going to convert into actual documents, which are the rows in the Parquet file. Okay, so seems to be doing something. Okay, so it's still running. Yeah, it generates so two PDF files are converted into 8 different documents. Okay, so it came back. So you can see it generated for 2 PDF files. It generated 2 documents, and here are the rows. So it maintains source file name. So there are two PDF files, and every document got a document ID. And this is the content, even though we cannot see it here. But this is all PDF content in a JSON form. So this is one of the JSON, and you can see it actually has page numbers in it. What is on page number 1? This is the hash, and this is the different sections of PDF, where there are boxes, there are tables, and it's gonna give you more details about what is in the PDF. So this is one example of what is in that mars.pdf. Okay, so let's take that through a document chunking. So because PDF can be multiple pages and with different sections, so we want to convert those PDF into actual documents. And this is a stage for converting PDF to docs. And it is, again, another pipeline. You can see doc chunk Python transform. So it is in those list of transforms I was showing. This is one of the existing transform. As I said, you can use one of the existing transform, which are more than like 20, 25 at this moment. New are being added as we speak. Or you can bring your own transform, or you can take existing transform, extend it, and add your own functionality to it. So let's see, after chunking, it created these 8 documents. So you can see this the solar system part is appearing 2 places because both the PDFs had that solar system content duplicated in 2 places, and you can see it has generated 8 documents out of which, and there's a file name along with it. So there are 4 documents from Earth and 4 documents from Mars.pdf. Again, and you can see these are the documents, and this is the content of one of the column of the Parquet file. And these are different chunks belonging to different files. Now let's run through an exact dedupe. So again, exact dedupe is same way. It's one of the transform available, and you can see it has a similar structure. It has an input and output location and a configuration. And right now, as things happen, while I was sitting here, I discovered a bug that what is happening here is I kept the document ID same for the documents. So all 4 documents has the same document ID, and the other 4 has the same document ID. And that's why instead of removing the duplicates, it removed the non-duplicates, and I left with the duplicates. Right. And the pressure of delivering a talk, I couldn't fix it. But you get the idea, and I will fix this notebook. It has file name and content. You can see there are 2 documents are there, but there in a perfect world there are 7 documents here with 1 duplicate removed. Then we generate a document ID, so it adds a new column to the Parquet. So input is without that column, output will be a document, same Parquet, but 1 additional column called hash and integer ID column. Then this is what it looks like, where now we have, along with this, we have a hash and integer ID column as well. Then we run through a fuzzy dedupe where it actually looks for, it does a bigram or 3 grams or 4 grams based on the config, and tries to find out, are there any duplicates which is close enough or similar enough. And this is the different settings we can make. And this is very important because you don't want to remove too many, you don't want to be too aggressive while removing the fuzzy dedupe, because then you may lose something good. Because if something, and it's always a fine line of data processing, that if something appears on internet more, then maybe it is more useful, right? So it is not always a bad thing. So as a data processing engineer, you need to walk in a fine line between what is too much versus what is too less, and it applicable with anything. For example, if you be too aggressive with removing hate, abuse, profanity content, then you may not have a model which is talking in the real world. It may talking in some perfect ideal world. So so it's always a fine line. And likewise, you can stitch a different pipelines, data processing pipelines together, where output of one becomes input for the other. And the last part is going through encoding. And even for encoding, there is a Python transform configuration where it's a transformer built for creating encoding. And then you can take that encoding and put it in any vector database, possibly Milvus. Only one vector database, which is Milvus, and take it further. So this is what I have, but this data prep kit is open source project, and we are looking for developers for fixing for any open source project. We need a developer for documentation, issues, contributing new transforms, maintaining the code base, and so on. So if you are interested, please feel free to get in touch. And thank you so much. Yeah, sure.
Like a data set is about those bad professions.
Right.
Like suppose the criminal and crimes. So
Right.
like what the data set would analyze when put through the data.
Right. So yeah, as you said, right? So what is good data and bad data depends on the purpose, right? For example, for English only model, any non-English content is a bad data, whereas for any non-English model, English content is a bad data. So it depends. Again, then you tune your parameters for the filter, or you arrange a filter in such a way that you get what you want. And I think that is more challenging part, is to, because there is no way you can look at the data. You cannot look at the 1 terabyte of data and see how good quality it is. So at some point, and one important aspect I forgot to mention is ablation studies. So no matter whatever configuration you come up with, there's no way to know whether it is really working or not unless you tried. And you cannot try it on full model. You cannot train a full model and then realize, oh, it has these issues. So that's why we have to rely on a smaller model. So take a percentage of data, take a smaller model, train the data. We call it ablation studies, and then compare the effect of particular filtering. So if you change fuzzy dedupe from 0.7 to 0.6, it may improve or it may degrade the performance. How do you know? By actually doing the ablation studies. Yes, right. So there are test benches, which is there are various different. So we have like 15 different score standards, and you always compare. For this ablation studies, this was the change in data, and this is the result that for these 5 test bench, it is improved the result, whereas for these 5, it degraded the result. And what is the overall average effect of it? And based on, for example, for IBM, for us, the enterprise use case is more important than the general. So we may not focus more on poetry part. And for that workbench, it's okay if the performance is not as good as the other test bench.
You can recommend for like choosing a smaller model to find?
You mean the smallest possible, or?
Yeah, just in general, like what's the best way to go about
Yeah.
making the small model?
Hugging Faces has done a really good job at that, where you can go on, look at the model card. So it's almost like it's like a bio. Yeah. I mean, leaderboard tells you which model doing very good, but and you want the reason you want to select the smaller model is because maybe you want to run on a smaller machines on your laptop, or on a limited number of GPUs. And Hugging Face gives you, for every model there, you can select based on the size, and then you can look back at every model and see what its strengths and weakness. Right. So, and that's where these frameworks are useful, because everything works for the smaller amount of data. When the scale increases, things starts falling apart. And that is the reason these frameworks support Sparks and Ray runtime, because that way you can scale it to as much as you want. So Ray, in my experience, is a great system without any complexity. It gives you ability to scale, and it can, for example, some of the data cleansing process can take 24 hours on hundreds of worker nodes.
IBM multinational. How are you guys dealing with the new AI Act? Or it's, I guess, in April? I don't know if you're following that, but like, we stopped even introducing some of the stuff that I think Grok was sanctioned for.
Right.
The Twitter data that they.
No,
Are you guys following that at all?
I'm
building around?
Yeah, I'm sure IBM is following that. I think IBM is known on following these guidelines as good as anybody or better than anybody. Personally, I'm not familiar with that area. I like to think not in limits. So do something, and then limit may curtail your abilities, other than starting with limits and then you reach nowhere. A personal statement. Okay, IBM is doing what it has to do, but I'm not sure. Yes, sir.
With text scraping or the documents on that pass into the framework, they might be very coarsely collected. Where would you recommend, or how would you recommend to do some sort of creation to make sure that the result before training is still matching the context of my application or model?
Right. So again, you can write your own transform in this case. For example, a lot of data has a lot of HTML content in it, right? So if you just throw that to a model, it will learn the HTML language than English, right? So so that's where these transform comes in picture, where you remove the HTML tags, you remove the headers and footers. For example, in case of IEEE paper, there are there is a defined header, defined footer. So such data sources are easy, but when it is internet, there's always when you tune something, when you filter something, you always has a chance of filtering out the good content also. So it's always a fine balance. Sorry, I not able to hear. So your question is about healthcare? Yeah, I think I have not seen a specific healthcare database, but there are a lot of workbench which is you can measure your model performance with the healthcare category of question answers.
Just pick for the database, link with the PDF and the HTML files, like is there any other types of files, text files?
Yeah, you can use any format. You can use text or you can use common crawl is in WARC. So you can use any format. And if there is no existing transform, you can always write your own. Yes, sir.
On a small scale, I can do it with spacing or the usual NLP.
Right.
What is the break point where I should transition to such a framework?
I think maybe 2 laptops. 2 laptops
Too
more
many
than,
doctors.
yeah, too many.
Take any pizza, drinks, the cooler is full of drinks we brought that you could take home. I don't want to carry them. So please take pizza, there's soda, seltzer, water.
Thank you, everyone.
And thanks to all the speakers, great work. See you again next month, probably here, probably the same room.
Did you stop?